So in this question, we've got a particle which moves by the action of two forces. Now we're listed here and they're in vector form. So force 1 is 1.6 I minus 5j, so that's the I and j components, and it's in newtons. And force 2 is ki plus 5kj newtons, so that's the two components for that one. Now it's accelerating at 3.2 I plus 12j, so that's the two components there, meters per second squared. That is pretty standard, as is the newtons. And so here we can see we've got two variables, k. Now k is a constant. What we want to do is find out what value it is. So how are we going to work that out? Now we've got two forces and we've got acceleration, and it's given in meters per second squared and newtons, which is the standard units. So here we'll be looking at Newton's second law to try and solve this for us. So we've got force equals mass times acceleration. So what is the forces on these? So let's add them up first. So forces here are 1.6 I minus 5j and ki plus 5kj. So let's add them up. So we've got 1.6 I minus 5j, and then add to that force ki plus 5kj. So if we add up the I components, we've got 1.6 plus k. So let's put that in here, 1.6 plus k, and that's I. And then for the j, we've got 5kj and minus 5j. So we can rewrite that as add to that 5k minus 5, and that's the j component. So that's the two vectors added together. Okay, now we know that force equals mass times acceleration. So here, as it's given in newtons, what we can now set up is that 1.6 plus k, that equals mass times 3.2. So it's m times 3.2. So I'm just going to write that as the other way around, 3.2 m. Now the second one for the j component, I've got 5k minus 5, and this one here is given as 12. So 5k minus 5 equals 12 times the mass. So that's mass times acceleration. Okay, now what I can do here, I can multiply this top one by 5, thus getting a 5k, eliminate my k, and I can get m for my mass. So let's multiply this one by 5. So that's equation 1, that's equation 2. So equation 1 times 5, let's do that. So 1.6 times 5 is 8. So I'm going to write that here with the number 5k, and then that equals 3.2 times 5, that's going to give me 16. Okay, so this one here, that's going to give me a plus 8. So now what I can do is now subtract the two together, keeping separate from this. So subtract them, 5k minus 5k, that disappears, minus 5 minus 8, that gives me minus 13. And then 12 minus 16 gives me minus 4. So that's minus 4m. So now I can solve for m by dividing everyone by minus 4. So therefore m equals minus 13 over minus 4, which just equals 13 over 4. So now I've got the mass. I can now substitute that in, hopefully find k. So which is the easier one to work with? Well, you could use either or, but I'm liking the look of this one. So I'm going to go with equation 2. So equation 2. So I've got 5k minus 5 equals 12 times this. So equals 12 times 13 over 4. Now look at 12 and 4, I can divide everything up by there. So now I've got 5k minus 5 equals 12 and 4, that cancels out, gives us a 3. So now 3 13s 39. Okay, add 5 to both sides to get the k on its own. So 5k equals 44. So k equals 44 over 5. Or if you want to write that with a number, you can do 8 4/5 or 8.8. Or 8 4/5, whichever way you want to do. So therefore we've found our constant k, 8 4/5, 8.8 or 44 over 5. Either or is good. Okay.